So continuing with this section, 1.7, working with composite functions and also adding, subtracting, dividing, multiplying, where you're introduced to this new notation here, which has us adding these two functions, f of x and g of x, also subtracting, also multiplying, and dividing. You might notice that they don't actually write out the complete f of x and g of x. They just have f and g. They're implying that you know which function that they're talking about. We'll also be evaluating the domain for each of these. So if we kick straight into adding these two functions, f of x and g of x, we're lucky enough to see that there's a pattern between these two rational expressions. I'll give you a moment to try and see what's common between these two. So hopefully you're able to notice that the two denominators are the same. We have x squared minus 16 for both of these. So since those are fair game, we have the same denominators, we can continue to just combine like terms on the top. So if we combine 3x and 5x, that gets us 8x. Positive 2 adding on negative 4 gets us negative 2. And then this is all over x squared minus 16. Previously, we were talking about how the domain can be written in interval notation. If we solve this, eventually trying to find what values in the denominator will make this equal to 0. Hopefully you can say that x cannot be equal to positive or negative 4. When you solve this, whether you notice it's a difference of squares and you factor and solve that, or you just have x squared minus 16 cannot be equal to 0, and then solve that, saying that eventually x squared cannot be equal to 16. The only options there are positive and negative 4. So that's the first part. If we are subtracting the two, same kind of setup as we had here, we'll rewrite it. 3x plus 2 over x squared minus 16. We're subtracting that second fraction. So where I see students trip up is that they'll just subtract the first term, but keep in mind, we're subtracting this entire fraction. So we still have the same denominators, but keep in mind, we're subtracting the entire fraction. So we should really be thinking of this as 3x plus 2 minus 5x, because if we distribute to that, it's negative 5x. And then subtracting a negative 4, which is really adding on 4. Keeping in mind this is all dividing by x squared minus 16. If we combine like terms from there, 3x and negative 5x gets us negative 2x. 2 plus 4 gets us 6. This is all over x squared minus 16. Getting us the same type of domain that we had previously. We can have everything up to negative 4 in union with the numbers in between negative 4 and 4, in union with 4 to infinity. So a lot's going on in this one. So if we circle what we've done so far, we got the domains, we've got differences, same domain in this case. If we continue with multiplication and division, that's going to take a little bit more time. It's nothing we can't handle. It's just going to be channeling a lot of Algebra 2 skills, which as we see, are coming back again and again. So I'll get another piece of paper for this one. So if we are now multiplying f with g, same thing as f of x times g of x. We have 3x plus 2 over our denominator. These can get a little tedious if the equations have a lot going on to it. Hopefully you're thinking of multiplying both of these and foiling them. Not too sure on where you want to start, but we'll start with the top. So keep in mind we're foiling here. So 3x times 5x gets us 15x squared. 3x to negative 4, subtracting 12x squared. Or sorry, it's just subtracting 12x. 2 to 5x adds on 10x. 2 to negative 4 gets us negative 8 at the end. If we multiply the bottom part, we have x to the 4th now. And we're subtracting 32x squared eventually when we combine everything there. And then finally adding 256 at the end. So as we see, there's a lot going on here. If we want to simplify the top part, this is going to be 15x squared, negative 2x, minus 8, all over x to the 4th, minus 32x squared, plus 256. For this one, I'm pretty sure that it's all real numbers. Just so we have closure on this, we'll graph it out, even though it's a lot going on. So we have, we'll use parentheses because this is a fraction. We have 15, x and its squaring, subtracting 2x minus, put it back down, minus 2x, minus 8, all dividing by x to the 4th, minus 32 x squared, no. Plus 256. So we kind of have the same idea here with the domain. As we see when this is graphed out, it looks as if it's hopping over 4 and negative 4 once more, which makes sense because in the denominator, those are still going to be the hot commodities. Even if we were to rewrite this as how it was originally, this is still x squared minus 16 being squared over all this, where this still has a domain where x cannot be equal to positive or negative 4. So same domain, even though the bottom part has a little bit more to it if we expand that. Division won't come up too much, especially because these are pretty strenuous. There's a lot going on with these. It's going to be kind of a pain, but we'll soon see that a lot of cancellation happens. So if we have this, f of x dividing by g of x, these are both fractions, so we'll leave a lot of space for this. So f of x we have is 3x plus 2 over x squared minus 16 dividing with 5x minus 4 over x squared minus 16. We still want to make sure that there's some closure on these fractions, because if these fractions end up with 0 in the denominator, it's not going to work. So for our domain, we know that we want to have x still not equal to positive or negative 4. Since we're dividing by fractions, hopefully you remember this from way back when, we can evaluate this as the one fraction, 3x plus 2 over x squared minus 16. Now multiplying with the reciprocal of the denominator, which was flipped around, x squared minus 16 over 5x minus 4. Since we're multiplying across here, that's an option, but you might want to pause real quick and think, is there anything we can cancel out? Is there anything that we already have on the top and the bottom? So hopefully you're noticing that we have x squared minus 16 in the denominator here and in the numerator here. If you're not convinced, we can buddy up everything together. I think this is where students feel more confident canceling out terms, just because it has parentheses around it for some reason. Leaving this set up here. So now it looks as if it's more suitable to cancel x squared minus 16. If you weren't convinced at first, hopefully this seals the deal. If we take this further, when simplified, we're just left with 3x plus 2 dividing by 5x minus 4. So this is considered f over g. Think real quick, is there anything else that might be considered exempt from the domain? Hopefully you're noticing this 5x minus 4. It's still hanging out, still in the domain. We wouldn't want that to go to 0, even though everything, when simplified, gets us here. So we can take this further. We'll put a domain question mark there, because although we simplified it, there's still a little bit more to show from the domain. So if we have 5x minus 4 equals 0, solving this, 5x equals 4. Eventually, we want to say that x cannot be equal to 4/5. So that's something we also want to include in our domain. So our domain seen here, x cannot be equal to positive 4, negative 4, or positive 4/5. When simplified, f over g is 3x plus 2 over 5x minus 4. Lots going on this one.